benchmark next week is 25 questions, and 10 of them will be about y equals mx plus b in some form or another. And a lot of them are specifically matching the equation to a graph, or you could say matching the graph to the equation. So you have to know how to do this. And I've gone over this multiple times. This is your last shot at understanding it. So please try and pay attention. Like I always say, the best way to do a multiple choice problem, specifically when you're trying to match an equation to a graph, is to eliminate wrong answers. And you can eliminate wrong answers by looking at the y-intercept. Where does this line cross the y-axis? Hopefully you know that the y-axis is this one and this is the x-axis. That would be helpful. The line crosses the y-axis 1, 2, 3, 4, 5 spaces up. That means it's positive because it's up from the origin, and it crosses at 5. So your y-intercept is 5. That means you're looking for an equation that says plus 5. Not 5x. The number that's with x is the slope. The number that's by itself is the y-intercept. So A says plus 5. That could be right, that could be right, that could be right. D is definitely wrong. We can eliminate D right away because that says minus 5. That would mean the line would be crossing way down here somewhere at negative 5, and that's not what we had. Okay, so we eliminated 1. That's helpful. Another way you can easily eliminate problems is by looking, is your line going down to the right or is it going up to the right? Well, this line is going down to the right. Since it's going down, what does that tell you about slope? Yes, it tells you that slope is negative. So we look for a number in front of x that is negative. There is no number in front of x. That means it's a 1. But more importantly, it's positive. There's no negative sign there. Since it's positive, this equation, if you were to graph it, the line would have to be going up. Can't be that one. Our line's going down. This one's negative, that one's negative. So there you go. You've narrowed it down to 2 choices without really even doing anything. That's the beauty of these types of problems. So both of these have the correct y-intercept. Now we have to determine which one has the correct slope. They're both negative. One of them is negative 5. That means negative 5 over 1. That means it's going down 5 and over 1 from one point to the next. This one does not have a number in front of it. That means it's a 1. You could put it over 1 just like we did the 5. So we have our rise over run. That means it's going down 1 and over 1 from one point to the next. Well, this line is crossing on our graph paper right at every grid. So we've got plenty of points to choose from here. That's nice. And it's in fact going from one point to the next. Down 1, over 1, down 1, over 1, down 1, over 1. So it's choice C. Down 5 over 1, if you think it's B, that would be down 5, 1, 2, 3, 4, 5, over 1. Your line would look like this. That's choice B. That's not what we have, so it's not choice B. It's choice C. So again, please, on these types of problems, look at your y-intercept. Look at if your line is going up or down and eliminate wrong answers. It's going to make your life a lot easier. Another thing that you're going to have to do, let's see if that all fits on my screen there. Yeah, let's see it does. All right, it's a little bit. There we go, that's better. You can see everything now. Okay, another thing you're going to have to do is find x and y intercepts from an equation. This is a little bit more complicated. So how I'm going to explain this to you is that if you have a graph and it crosses the y-axis, the first coordinate in your ordered pair is 0. So what does that mean? It means this right here. So let me use this to explain what I just said. Here's part of a line, just some random line that I drew. I don't really care about the whole line. I just drew the part of the line that crosses the y-intercept. All these little dashes here are just random lines that I'm going to use to try and make a point. Right? They have nothing to do with this equation. Forget about this equation for now. I'm using this to try and make a point here. And I want you to recognize a pattern. Let's say your line crosses the y-axis right here. That point is 0, 4. That's the coordinate of that point. If I said plot the point 0, 4, you would go left and right 0, and you'd go up 4, and you'd plot that point. That's that point. Let's say it's a different line. Let's say we got a line that crosses right here. That's the y-intercept would be 0, 1. Let's say it crosses way down here. That would be 0, -3. What do all these points have in common? The x-coordinate of these points are all 0. And that's what I'm trying to show you here, is that it doesn't matter where the line crosses the y-axis at, the x-coordinate is always going to be 0 for a y-intercept. Always. Because no matter what point you pick on the y-axis, you're moving left and right 0, and you're just moving up or down to that point. So we're going to use that. We're going to use that. I'm going to come back to that. Same thing goes with the x-axis. If you're trying to find an x-intercept, it doesn't matter where your line crosses the x-axis. Let's say it crosses way over here. Your x-intercept would be 5, 0. Let's say it crosses over here. Your x-intercept would be -2, 0. Let's say it crosses way over here. Your x-intercept is -5, 0. What do all of these points have in common? The y-coordinate is 0. Because when you pick a point that's on the x-axis, you're going straight across to it, and you're not going up or down. You're going up or down 0 spaces. Okay, what does all that mean? It means we have to use that information in this equation to find x and y intercepts by substitution. That's why I drew this table here. So let's find the y-intercept first. Let's figure out what is the y-intercept from this equation. Well, it's going to be some point that crosses the y-axis that is 0, a number. So whatever our y-intercept is, the x-coordinate is 0. The x-coordinate is 0. The y-coordinate, we still don't know. How do we figure it out? We plug a 0 in for x. That's the technique. I could have just told you that right off the bat. To find the y-intercept, plug a 0 in for x. But it wouldn't have meant anything to you. Now hopefully you understand why you plug the 0 in for x. Because when x is 0, you solve for y, and that's your y-intercept. So let's do that. If we plug a 0 in for x, anything times 0 is 0. So 4 times 0 is going away. That's just going to be 0. That's gone. So we're just going to end up with -6y is equal to 24. You solve for y by dividing by -6, and y is -4. So there's our y-intercept, -4. We just found it. It's that easy to find y-intercepts. You just simply plug in a 0 for x, solve for y, that's your y-intercept. And finding an x-intercept from equation is just as easy, but instead of plugging in a 0 for x, maybe you figured out that you plug in a 0 for y, because no matter where our x-intercept is, the y-coordinate is 0. And that's what an input-output table is. It's just coordinates. It's just points on your line. It's just a bunch of points on your line. You could plot all these points, connect them, it'd be a nice pretty line. All right, so let's plug a 0 in for y. You plug a 0 in for y, and just like the x, it's going to disappear. Anything times 0 is 0, so the 6y disappears, and you're just left with 4x is equal to 24. You divide by 4, and x is 6. So there you go. You're done. When you're given an equation, and they say find the x and y intercepts, you just plug in a 0 for x, and that'll tell you the y-intercept. You plug in a 0 for y, that tells you the x-intercept. And this can work backwards too. Like they might just give you the table. All this stuff here might be gone, and they might just give you the table and say find an equation of the line for that table. Well, all you need for an equation of a line is slope and y-intercept. And y-intercept is whatever number in the y column is straight across from the 0. We just figured that out. So our y-intercept is -4. Our slope, how do you get from -4 to 0? You add 4. How do you get from 0 to 6? You add 6. So our slope is 4 over 6, which reduces to 2/3. So there you go. You found slope and y-intercept from a table. You guys know how to do that. So if they say find the equation of a line that matches this table, that's how you do it. You find the slope and the y-intercept from this table, And then you just plug it into y equals mx plus b. Y equals 2/3 x minus 4. And you're done. All right, one more thing I want to show you today before I release you to start doing the problems in the do section. And that is something even more simple than what we just did, but similar. And it's finding x and y intercepts, but this time from a graph, not from an equation. Which is much easier because they already graphed the equation for you. So you can just look at it and see where the x and y intercepts are. You don't have to plug in numbers and figure it out for yourself. So you just look at this graph. Where does it cross the x-axis? 1, 2, 3 spaces over at 3, 0. Where does it cross the y-axis? It crosses at 0, down 5 spaces, -5. So if it says find the x and y intercepts, you just found them. This is the x-intercept. That's where it crosses the x-axis. This is the y-intercept. That's where it crosses the y-axis. The only way this could become a little bit more tricky is that usually nobody includes the zeros in the x and the y-intercept. Because like I said on that last slide, for your x-intercept, the y-coordinate is always 0. And for the y-intercept, the x-coordinate is always 0. So it just gets redundant to keep writing it in there. So they usually just use the number. So x-intercept on this would equal 3, and y-intercept on this would equal -5. And you could write the whole ordered pair, but it's more writing, and in math, they always write as little as humanly possible. So this would be -5, and that would be 3. And then same thing down here. Your x-intercept over here is at -4, so your x-intercept is equal to -4. Your y-intercept is down 2 spaces. Y equals -2. I think the only reason I gave you 2 examples here is to show you that the slope doesn't matter when you're trying to find x and y intercept. It doesn't matter if the line's going up or going down. You don't have to worry about slope. You're just looking to see where the line crosses the x and the y axes. So there you go. Some of the problems in the do section today are what we did the last couple days because it's benchmark review, so you got to know how to do everything. Don't forget about what we did the last couple days. It's rate of change. It's substituting into a function, evaluating a function at a value. So there's a lot of this on today's do section, but there's stuff from the last couple days as well.